Hello, this is John from TC Math Academy. And in this particular video, we are going to solve this rational equation. And let me just kind of tell you right now, this is going to require a good amount of work. However, if you're in a course like Algebra 1, certainly Algebra 2, College Algebra, Pre-Calculus, courses like this is a problem you should be able to do. So if you can figure this out, go ahead and put your answer into the comment section. I'm going to show you the correct answer in just 1 second, and then I'm going to go through a series of steps to solve this rational equation. And if you're not familiar with anything that I'm doing along the way, I'll give you some suggestions so you can improve in this very, very important algebra topic. Also, if you need math help with the course you're taking, test prep or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to it in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let me go and show you the answer here. And of course, we are solving for x. And again, the description of this type of equation is what we call a rational equation. These are what we call rational expressions. Essentially, they are fractions with polynomials and variables. There's kind of a more technical definition here, but basically, kind of think of it as a fractional equation with variables, i.e. a rational equation, because we do have an equation symbol here. So what is x equal to? Well, let's go ahead and see the answer. X is equal to 2. So that is the answer, and you might be kind of surprised that after doing all this work on this big equation that x is equal to 2, but in fact that is the answer. So if you got this right, that's very, very good. Matter of fact, let's go ahead and give you a nice little happy face and A plus, a 100%, and a few stars so you can tell your friends and family that you're able to conquer a nice rational equation. All right, so I'm going to go ahead and get started on the steps here, and there is quite a bit of steps. So if you were trying to learn rational equations for the first time, this is not the type of equation or the level of difficulty you would want to start in. But basically, what we need to do is effectively factor all the denominators. Then we want to find the lowest common denominator. Essentially, we want to kind of clear the fractions. But in this particular problem, you'll see there's kind of a little bit of a twist here. So the couple skills that you need to have to solve rational equations is, one, you need to just be able to solve a various different types of linear equations, quadratic equations. You should be already pretty good with that stuff. Certainly need to know how to factor, okay, different polynomials, trinomials, things like this. And then you're going to have to basically be very, very good with fractions and all this other kind of good stuff. So I'm going to go ahead and get started here. Now, you can see that this denominator is already factored, this denominator is already factored, but this trinomial, x squared minus 4x minus 32, we can factor, and here is the factors. It's simply x plus 4 times x minus 8. Now, if you are struggling with any of these skills here and you need additional help, I do have a lot of different videos on my YouTube channel that can help you out with any kind of sub-skill that I'm covering. But really what you might want to do is check out like my full Algebra 1, probably like my Algebra 2 course to really learn this stuff. Okay, now a little bit of a tip here. If you are, taking a quiz or a test or doing a homework problem, and you see a trinomial like this, and you're trying to factor it, let's say you're just struggling to factor that trinomial, take a look at these other linear factors in the other part of the equation. Oftentimes, these turn out to be the factors of this trinomial, but again, you need to know how to factor trinomials. And it turns out that when we factor this, it's just basically this times this. All right, so now what we're going to do is rewrite this equation with this. We're going to replace this x squared minus 4x minus 32, and we're going to put in those factors right here. Okay, so when we do this, now we can find the LCD, because we kind of want to think about clearing the fractions here. Now, in this particular case, I'm going to take a different kind of approach, but you still need to always find the LCD, or you always need to be thinking that you need to find the LCD. Okay, so again, I want to show you a different kind of way that we're going to approach this, but as you kind of go through like a checklist or procedure when you're solving a rational equation, you need to be thinking, okay, what is the lowest common denominator so you can clear the fractions. But in this case, and by the way, I could use the LCD to clear the fractions here, but I'm going to show you a different path that I'm going to take. But in this case, the LCD is nothing more than x plus 4 times x minus 8. Now, if you don't know how to find the lowest common denominator of rational expressions, again, this is something that's very, very important. Effectively, what we need to do is just take all the factors of the denominators and multiply all the unique prime factors, which would be this right here. All right, so what's the next step? Well, we need to get all the denominators the same. So this being the LCD, well, this one is okay because this fraction here, or this rational expression, has LCD, but we're going to have to fix up these two right here such that they contain the lowest common denominator. All right, hopefully you're not struggling right now or getting lost. So if you're with me, that's excellent. So let's go ahead and work on rewriting this rational expression and this rational expression such that they have this full denominator, i.e. the lowest common denominator. So let's go ahead and take a look at changing 3 over x plus 4, and we need to get that LCD in here. So 3 over x plus 4, well, we have the x plus 4, but we don't have the x minus 8. So what can we do here? It's easy. We just multiply both the numerator and denominator by x minus 8. This is effectively the same thing you do when you're working with numeric fractions. Now, if you've been following me with my other videos, I do a ton of videos, basic math to advanced math. I do a lot of like basic elementary level fraction, middle school stuff, because these concepts of finding the LCD or we're dealing with fractions are tremendously important in algebra. Okay, so if you're struggling with this, you need to kind of go back and do some basic fraction review. Again, I have videos and courses for all that stuff. All right, so here, again, we're going to multiply both the numerator and denominator by x minus 8 so that the denominator is the LCD, and that's what we want. And we'll clean up the numerator here. We'll go ahead and just distribute this 3 into x and this 3 into 8. So we have 3x minus 24 over the LCD. Okay, so that is taking care of this rational expression. Let's go ahead and do this right here, this one next. You can see here that, on your paper as well, it's going to be difficult to do all this kind of working this way. So you kind of need to kind of break up these steps because you're just not going to be able to work through the span of your paper, right? So your paper is in portrait. So, these problems do require quite a bit of steps. So stylistically, you might want to do, work the problem the way I'm kind of working it. All right, so again, the next thing we're going to do now is rewrite this fraction. So 2 over x minus 8, such that it has the LCD. Let's go ahead and take a look at that right now. Okay, so here, again, this has x minus 8. And its denominator, what we need is the x plus 4 part, so we'll multiply that by x plus 4 and the numerator by x plus 4. And when we clean up the numerator, we get 2x plus 8, and here you go. Okay, so here is our original problem, okay, with the, well, actually we have this denominator over here factored out. So this is the LCD. So we don't need to change this rational expression, but these two here we did change. And you can see, I kind of really shrink this in so you can see everything. This is why, when you're working a problem like this, you really need to be neat and organized and just double check your work because you can easily make a mistake. I can guarantee you that you won't make mistakes in mathematics. I still make mistakes, and I've been doing math for decades and decades and decades, and I do math every day for hours and hours and hours. You'll make mistakes. It's only human, right? We're not perfect features. And so basically, you'll write something down, and you'll have no idea why you did that. You'll look back, you're like, I don't even know why I did that. Well, because math is a game of focus, all right? You have to stay focused. You have to stay disciplined, and you got to double check as you go. So there's a lot of writing involved here. But basically, what we did is we rewrote this rational expression such that it has LCD, and this one such that it has the LCD as well. And then this rational expression here, already had the LCD. So these are two fractions with the same denominator, meaning that we can add these right here, okay? So that's what we're going to do next. But just to be clear about that, if I had like 3 over 7 plus 1 over 7, right? We're adding two fractions or two rational expressions. These denominators are the same. We can now add the numerator to clean this up. So that's what we're going to do right now. Okay, so again, I got this really kind of shrunk in here. Hopefully you can kind of see that writing. But being that we do have the same denominator here, we're going to keep that, and then we're going to add the numerator. So that would be 3x minus 24 plus this 2x plus 8. And of course, that'll be equal to the right-hand side of the equation. All right, so let's continue to clean this up. And I'll have to combine like terms. So 3x and 2x gives us 5x, negative 24 and 8 gives us negative 16. And that is finally now equal to the right-hand side of the equation. All right, so at this point, let's take a look at what we have. We have two fractions, two rational expressions that are equal to one another, i.e. a rational expression, or rational equation, excuse me. But if you notice here, the denominators are exactly the same. Okay, so if these are the same, and we're saying that this fraction is equal to this fraction, let me kind of give you kind of an example here. If I had x over 7 is equal to 1 over 7, okay, would I have to kind of solve this equation? Well, if the denominators are the same, then I'm like, well, I have this fraction is equal to this fraction. The denominators are exactly the same. So the numerators must be the same, and that's what we're going to do right here, okay? We're going to say, well, the denominators are the same, so the numerators must be equal to one another because we're saying the larger fractions here, or rational expressions, are equal to one another, okay? So we always want to work smart and efficient here. So let's go ahead and equate the numerators, and we can write a simple equation there that's basically 5x minus 16 is equal to negative 3x. And now we can just do some basic algebra, pre-algebra stuff and solve for x. So I'm going to go ahead and add 3x from both sides of the equation. I get 8x. I'll move that 16 over here, divide both sides of the equation by 8, and x is equal to 2. Okay, so that's how we got our answer. However, when you're dealing with rational equations, these type of equations, you always want to get in the habit of checking the solution, because oftentimes you can get what we call a extraneous solution, okay, which is like an extra solution. So at this point in the problem, you should just look at this as a possible candidate for being the solution for the actual original equation. Okay, so you might be saying, what are you talking about? Well, let me just show you real fast. This is an important point. Let's say I had x is equal to 2. Now, here is a lovely equation. It is like the nicest equation because what is the answer? X is equal to 2. Well, what number is equal to 2? There's only one number that is the solution. It is 2, right? So super easy, no problem. Now, if I multiply both sides of the equation by a number, okay, the same number, in algebra, you're allowed to do that. So you get 2x is equal to 4. So if I give you this equation, you'd be like, oh yeah, I could just divide both sides of the equation by 2. X is equal to 2. So it didn't break the equation, right? So multiplying both sides of an equation by a number is perfectly fine. However, when you multiply both sides of the equation by the same variable, this changes the ball game. Okay, so look here. So if I multiply both sides by x, I'm going to get x squared is equal to 2x. Okay. Now here, you so if I gave you this equation right here, x squared is equal to 2x, you'd have to move this over to the left-hand side. So x squared minus 2x is equal to 0. Let me erase this for a second. I'm making a real important point here because some students are not convinced that they have to do this. So let's factor out an x. So x times x minus 2 is equal to 0. So x is equal to 0 is one solution, and x is equal to 2 is another solution. So if you're watching this video, you're probably already at this level of mathematics. you'll understand what I'm talking about. So again, we started off with our original little basic equation, x is equal to 2, and then I started messing around with it by multiplying both sides of the equation by x, and then I solved that equation, and I got two solutions. So x is equal to 2 is the correct solution. This x is equal to 0. Okay, 0 is not equal to 2. This is like an extra solution. That's what we call extraneous. You got to throw that out. And you don't know that unless you check your solutions. You absolutely have to check your solutions and be on the lookout for these extra or extraneous solutions. Okay, so let's go ahead and do more work here. And you can't be kind of like, oh my goodness, this is like more work. It's like never ending. Yes, sometimes in mathematics, oftentimes, there is this level of work, but you can do it. Okay, so you got to have a good attitude. And so what we're going to do now, if you've already gotten this far into the problem, well, let's make sure or check to see if this is the right answer. So we're going to take this x equal to 2, and we're going to place all these x's here with 2, and then we're going to check to see how this turns out. Okay, we're looking to see if the left-hand side is equal to the right-hand side. Let's go ahead and plug in a 2. Here is the work all done. So we have 3 over 2 plus 4 over 2 over 2 minus 8 is equal to negative 3 times 2, 2 squared minus 4 times 2 minus 32. So when I simplify this, I get 3 over 6. This would be 2 over negative 6. And then we'll go ahead and just continue to work on cleaning up this numeric equation. So we have 3 over 6, which of course is equal to the fraction 1/2. 2 over negative 6 is negative 1/3 when we simplify this. And when I go ahead and clean up this denominator here, 4 minus 8 minus 32, that's going to be negative 6 over negative 36. You got to be really careful here. A lot of number crunching going on. All right, so now this fraction reduces. It's a negative over negative. That's positive. Positive 1/6. So let's go ahead and now add 1/2 plus negative 1/3. Easiest way to do this is to use this lovely bow tie method. If you haven't watched my videos on fractions, you definitely need to. Matter of fact, I think they're some of my most popular videos is on fractions. I have single videos that have millions of views because fractions is one of these particular things that people need help with. But anyways, there's a great shortcut method to add and subtract fractions. Here we can just go 3 times 1, that's 3, minus 2 times this 1, that's 2, over 2 times 3, which is 6. Or you could just find the LCD. Either way, you should be able to add these fractions, 1/2 plus negative 6. And when we do this, we figure you figure out that that is equal to 1/6. This side is equal to 1/6. So guess what? The left is equal to the right. So finally, we are done. And a lot of yours probably, steam is coming out of your head going, boy, that is a lot of work. Well, listen, I'm going to tell you right now, as you continue to progress in mathematics, this is really not that difficult. Okay, I remember being in my upper division math courses when I was getting my degree in mathematics, and oftentimes some of the problems would take, pages upon pages upon pages upon pages upon pages. Full pages of writing, da, 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 da. And guess what? You would hand that into your professor with that PhD, and they would say, sorry, you are incorrect. Matter of fact, I'll tell you one last quick story here. When I was a senior taking a course called Abstract Algebra, basically, at that point in our program, this was at the University of San Diego, there was basically only, we started off with maybe 100 people as a math major. By the time we got to where people were or their senior year, so many people dropped out. It was a very difficult program. We maybe had like 10 or 15 people left in the program. So in this particular class, I think we had like 6 people in this class. And when we got back our test, we got test scores like this, like 5 out of 100. And I can't remember what I got. I think I got like a 6 out of 100. I was panicked until I looked over at my fellow classmates, and some of them got like 4 out of 100. One got a 7 out of 100. But anyways, that is what you call the reverse of grade inflation. Our professors did not mess around, and if you didn't understand these concepts, they were going to let you know. But that's what makes you better, and we're talking a ton of work. So, if you are having a challenging time with math, it's all relative. There's people that are studying super advanced abstract mathematics, guess what? They have to go through the same emotional kind of process that you do, which is like, oh, this is a lot of work. You kind of doubt yourself, you work hard, you get frustrated, but that's the nature of, learning something. Okay. But it is worthwhile to learn mathematics, especially if you got to take a class and pass it. Okay, so again, a lot of steps here, a lot of concepts. If you need additional help with rational equations, check out either my Algebra 1, Algebra 2, or Pre-Calculus courses, College Algebra. I teach all of this in detail in all those courses. But if this video helps you out, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.